When it comes to the intriguing world of artificial intelligence, two terms often pop up: machine learning and deep learning. While they may sound similar, they represent distinct concepts within the AI landscape. So what's the difference and why does it matter? Let's explore this together in a more narrative style. To kick things off, let's talk about machine learning. Imagine you're teaching a child to recognize different animals. You show them pictures of cats and dogs, and over time, they learn to identify which is which based on the features you've pointed out. This is essentially how machine learning works. At its core, it's a subset of artificial intelligence that focuses on creating systems that learn from data. Instead of programming explicit rules, we feed the system data and let it learn from patterns. Machine learning can be categorized into three main types: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, you train the model on a labeled dataset. For instance, if you want to create a model that can detect spam emails, you provide it with a dataset of emails that are labeled as spam or not spam. The model learns from these examples and can then make predictions on new, unseen data. On the other hand, unsupervised learning deals with data that isn't labeled. The model has to find patterns and relationships in the data on its own. Think of it as organizing a bookshelf without knowing the titles. You might group books by genre or author. Lastly, there's reinforcement learning, where an agent learns by interacting with its environment and receiving feedback in the form of rewards or penalties. Imagine training a dog to fetch a ball. It learns to repeat the action that gets it a treat. Now, let's shift gears and dive into deep learning. You can think of deep learning as a specialized branch of machine learning that utilizes structures known as neural networks, which are inspired by the human brain. Deep learning is particularly powerful when it comes to processing large amounts of data and excelling in tasks like image and speech recognition. The beauty of deep learning lies in its ability to learn complex patterns through multiple layers of neurons. Each layer extracts different features from the data, allowing the model to understand intricate relationships. For example, in image recognition, the first layer might detect edges, the next layer might identify shapes, and deeper layers could recognize specific objects like cats or cars. So, what are the key differences between these two approaches? First off, let's talk about data requirements. Machine learning typically works well with smaller datasets, often yielding good results with just thousands of examples. In contrast, deep learning thrives on large datasets, often in the millions. This is because the complexity of deep learning models necessitates vast amounts of data to learn effectively. Another important distinction is feature engineering. In machine learning, you often need to manually extract features and identify which ones are important to feed into the model. This process can be time-consuming and requires domain expertise. However, deep learning models have the advantage of automatically learning features from raw data. You can input raw images or audio, and the model will figure out the important features itself, saving you a lot of effort in the process. When it comes to complexity, machine learning models are generally simpler and easier to interpret. You can understand how decisions are made, making it easier to trust the results. On the other hand, deep learning models are more complex and can often feel like a black box. This means it can be challenging to understand how they arrive at specific decisions, which can be a drawback in situations where transparency is crucial. Let's not forget about computational power. Machine learning requires less computational power and can run on standard hardware, making it accessible for many applications. In contrast, deep learning demands significant computational resources, often utilizing GPUs for training due to the complexity of the models involved. Now, you might be wondering about the real-world applications of these two approaches. Machine learning has a wide range of applications, including fraud detection in banking, recommendation systems, like the ones you see on Netflix or Amazon, and predictive maintenance in manufacturing. It's versatile and can be applied across various industries. On the flip side, deep learning shines in areas such as image and facial recognition. Think about how Facebook automatically tags your friends in photos. It's also used in natural language processing, powering chatbots and translation services, as well as in autonomous vehicles, where cars recognize objects in their environment. So, when should you use machine learning versus deep learning? It really comes down to the problem you're trying to solve. If you have a smaller data set and need a quick solution, machine learning might be the way to go. It's often faster to implement and easier to manage. However, if you're dealing with vast amounts of data and need to recognize complex patterns, such as in images or audio, deep learning is likely your best bet. In conclusion, while both machine learning and deep learning are powerful tools in the AI toolkit, they serve different purposes and have different strengths. Understanding their differences can help you choose the right approach for your specific needs. As technology continues to evolve, both fields are growing rapidly and finding new applications across various industries. Whether you're a data scientist, a developer, or just an enthusiast, there's always something new to learn in this exciting space.